gradient and a directional derivative. Find del r and del 1 by r. Okay, the position vector, we know already position vector is given as r equals xi plus yj plus zk. You just find out mod r. Mod r will give you root of x square plus y square plus z square. And of course squaring will give you r squared x square plus y square plus z. So you have to remember this one and this one, all the three, very important one. Now what is del r? Del r equal to dr by dx times I, partial dr by dy times j plus partial dr by dz times k. So del r is given as this. Now differentiating equation 1, you just differentiate this equation 1 with respect to x will give you 2r, see here 2r dr by dx, which is nothing but 2x plus 0 plus 0. So this will give you 2r dr by dx, which is equal to 2x. These two and these two will get cancelled. Then partial dr by dx will be x by r. Is it okay? X by r. So partial dr by dx will give you x by r. Similarly, you go to differentiate with respect to y. So we have 2r. See, we have 2r dr by dy. We are going to differentiate with respect to y. Will give you partial dr by dy, which is equal to 0 plus 2y plus 0. So this is nothing but 2y. Again 2 will get cancelled. Dr by dy will be y by r. So we have found a dr by dy. Dr by dz will give you z by r. Simple one. So we know that del r equals this expression. You substitute for partial dr by dx, substitute for partial dr by dy, substitute for partial dr by dz. So del r equals, instead of dr by dx, we have x by r. Instead of dr by dy, y by r. Instead of dr by dz, z by r. You substitute. Common terms here, this is also all those things, the denominator will be r. So we have xi plus yj plus zk divided by r. What is this one, xi plus yj plus zk? R vector. So r vector by r. See, so that del r will be r vector by r. Okay, so you have to find out del r. The answer is r vector divided by r. Next one is del 1 by r is asked. Del 1 by r is nothing but d by partial d by dx 1 by r times j plus partial d by dy 1 by r j vector plus partial d by dz 1 by r times k vector. First we will find out partial d by dx 1 by r. So d by dx, instead of 1 by r, 1 by root of x square plus y square plus z square. Correct? You just bring this term to the numerator. So that will give you x square plus y square plus z square to the power minus 1 by 2. You will have to differentiate with respect to x. So this minus 2 will come forward. So minus 2 x square plus y square plus z square to the power minus 3 by 2. Correct? Minus 3 by 2. Minus 1 by 2 minus 1. So that will be minus 3 by 2. You will have to differentiate this with respect to x. So that will give you 2x. And these 2 and these 2 will get cancelled. So we have d by dx 1 by r will give you minus x divided by x square plus y square plus z square to the power 3 by 2. Similarly, d by dy 1 by r will give you minus y divided by x square plus y square plus z square to the power 3 by 2. Similarly, d by dz of 1 by r will give you minus z divided by root of x square plus y square plus z square to the power 3 by 2. See, the same form, same method. So we have differentiated with respect to y, we have differentiated with respect to z. So minus I. Now we will have to add all those things. So del 1 by r is given as this expression. So we will have to add all those things. So denominator, look at the denominator, all are equal. So you can add directly. So that will give you minus xi minus yj minus zk. What is this one? This is taking minus sign out, that will give you minus. What is this one? Xi plus yj plus zk, r. So r vector divided by, what is this one? X square plus y square plus z square, r square. R square to the power 3 by 2. That 2 and this 2 will get cancelled, you have r cube. I repeat, see here. So this is nothing but your r squared. R squared to the power 3 by 2. So you have 2 will get cancelled, you have r cube. So del 1 by r is nothing but minus r vector divided by r cube. Prove that del e power x square plus y square plus z squared is given as 2 e power r squared r vector. Okay, so we are going to prove left hand side equal to right hand side. We are going to prove. The position vector, we know already position vector is given as xi plus yj plus zk, and mod r is given as this, and of course r is given as this. So we know already this, very simple one. And del r is given as this. Also we have del r is expressed as this. Del e power x square plus y square plus z squared is nothing but I partial d by dx times your this is given as this is e to the power x square plus y square plus z squared. Similarly for j and similarly for k. So you have to differentiate with respect to x first. When you have to differentiate with respect to x, you have e power x square plus y square plus z. As it is, you have to write. For exponential, you have to write as it is. Then you have to differentiate. When you have to differentiate, that will give you 2x. You have to write as it is. You have to differentiate with respect to y here. So 2y. See, when you have to differentiate this with respect to y, 0 plus 2y plus 0. So 2y. When you have to differentiate this with respect to z. So you have 0 plus 0 plus 2z. See, 2. So 2x, 2y, 2z. Just take the common term out. So you will have to take the common term out. So that will give you xi plus yj plus zk, which is nothing but your r vector. So this can be written as 2e power r square r vector, which is right hand side. See, right hand side is given as this 2e power r square r vector. See, r vector. So that's proved. Okay. Gradient of a scalar function. The gradient is a derivative or rate of change of multivariable function which is a component of for each direction. So phi is a continuously differentiable scalar function in the region of space. Then the gradient of del phi is defined as. So we know already del phi is given as I times d by dx partial d by dx plus j times d by dy plus k vector d by dz. Or also we can define grad phi equal to del phi. This can be written as summation over I, then j, then k. Okay, we can write this as exactly like this. Some properties, few properties are given. Del phi is a vector quantity. Del phi equal to 0, and it means that it's a constant. Del phi 1 dot phi 2. This can be written as, you just keep phi 1 del phi 2 plus phi 2 del phi 1. Del phi 1 by phi 2 is expressed as phi 2 del phi 1 minus phi 1 del phi 2 divided by phi 2 square. Del phi plus or minus psi will give you del phi plus or minus del psi. Okay, these are the properties of del. Example, phi is given as x squared y z cube plus x phi squared z squared. We will have to determine del phi at 1, 2, 3. So grad phi at 1, 2, 3. Phi is given as this. First we will find out d phi by dx. So we will differentiate with respect to x. When I want to differentiate with respect to x, will give you 2x y z cube plus y square z square. When I want to differentiate this with respect to y, will give you x square z cube, and this becomes 2y, correct? So 2x y z square. When I want to differentiate with respect to z, will give you 3z square, correct? So yeah, 2x square. No, with respect to z. So this will give you 3z square.